I'm going to review 9 examples where you get an expression and you're going to evaluate it given a specific value. And I'm also going to include, as you can see here, the different examples. I'm going to put chapters below so that way you can skip ahead if you're more interested in seeing a different problem. Example number 1, we have negative x. So keep in mind with this is a common mistake where notice we're substituting a negative 1 in place of x. This negative does not take into account this negative. So what I recommend in this case, if you see an x, just think about it. How many x's do I see here? Well, there's only one x there. So if I wanted to, I can say that this is really just negative 1x. And what I'm going to do now, if I see a number next to a letter like this, that automatically means we're multiplying those two things together. So now I can see we're just doing negative 1 is being multiplied with my value of x, which in this case is negative 1. So again, notice we have negative 1 times negative 1. Negative times negative is a positive, and 1 times 1 is 1. So my answer here is positive 1. Here's my next example. Similar to the last one, I'm going to rewrite this. So I see 1x squared here. So I'm just going to write it as negative 1x squared. And I know a negative 1 in front of a variable like this. That means we're multiplying this times my x squared. And now I see that I'm going to replace my x. But before I do that, just keep in mind that when we replace negatives, you got to be very careful substituting a negative when you have an exponent involved. So there's a couple ways you can do this. I'll show you one way. We could do negative 1 times, and I can expand. X squared really just means I'm multiplying x with itself twice. So the exponent 2 tells me I have two factors of x. Multiply them together. And if I substitute now, I get negative 1 times x, which is negative 1, times x, which is negative 1 again. And you can see here negative times negative. So if I multiply these two together, I get positive 1. Bring down my times negative 1. Positive times negative is negative, and 1 times 1 is 1. So the answer to this is negative 1. The other way that I was telling you is that I could put negative 1x squared, similar to the way I started the other one, which means negative 1 times x squared. And if I'm substituting a number that's negative, you can put parentheses around the variable you're replacing, right? Because I'm going to be replacing this x here. So in the next step, I take out the x, get rid of it, and I'm going to put a negative 1 in place of it. And if I follow the order of operations, I know I got to do exponents before multiplying. So negative 1 squared, I already know that means two of these multiply together, which is negative 1 times negative 1, which is positive 1. And then when you multiply these together, you get negative 1. So same answer, different approach. In this example, we're going to evaluate this expression when z is equal to negative 1. Notice there's not a lot of negatives involved in these problems. The reason why I chose negatives is because that's where 99% of your mistakes are going to come from, is when you're involved with negative numbers. This is the next example. What I'm going to do here is I'm going to take 4 minus 2, replace z with negative 1, and to the third power. And remember, a number next to a variable like this, which is called the coefficient, that means we're multiplying these together. So now if I do order of operations, we have minus, multiply, exponents. I'm going to do the exponents first. So I get here 4 minus 2 times, and now I just got to figure out what is negative 1 to the third power. If I did that work on the side, I know I'm multiplying negative 1 with itself 3 times. So the exponent 3 means I have 3 factors of negative 1 multiplied together. Negative times negative is a positive 1. Bring down my negative 1. Multiply this. That's negative 1. So here I know my answer is negative 1. So now I have 4 minus, and then before I subtract, I got to multiply. Order of operations. 4 minus, now here I have a 2 times negative 1, which I know is negative 2. Which gives us the new problem, 4 minus negative 2, which is the same thing as just saying 4 plus 2, which gives me 6. And another way that I recommend, if you have trouble with the negatives in this problem, is you could rewrite this problem as addition first and get 4 minus 2z to the third. So I could rewrite this as 4 plus negative 2 times z to the third power. So this is equivalent to this expression here, so I could rewrite it as that. And some of you may know it as keep, change, change. So keep it, change it, change it. And then you see we get 4 plus negative 2 times negative 1 to the third power. And we already did that calculation over here to the side. I know it's going to give me negative 1. So that's negative 1. And when I multiply this, you can see negative times negative is positive. That gives me positive 2. 4 plus 2 is 6. So I actually prefer doing it this way because, like I said, 99% of your mistakes, if you get it wrong, it's going to occur with the minus and the negative. So all that is going to confuse you. If it does, I recommend in the first step is to rewrite any subtraction in your problem as addition, and then that should make it a little bit easier. Next example, you can see a lot going on here. But when you first see a problem, do not get intimidated because it's always going to be the same steps. You're going to substitute the given values in place of your variables and then follow the order of operations. So first thing is negative. X, how much is x? That's -1. I have an exponent a, which is 2, so I'll put that here. Minus, what is y? Y is -4, so -4. And notice if I replace a negative in here and there's a minus sign, I put the negative a little bit higher so I can differentiate. This is not my minus. This does not take into account the minus sign, so be careful with that. The y is -4, and we still have a minus sign there. Close this up, and then b is your exponent, which is +3. Now we just follow order of operations. I have parentheses, exponent here, so always step 1 is parentheses. So in here, I got an exponent and subtraction. Exponent is first, so we're going to get -1 to the second power, which means -1 times -1. And just going back to this real quick, notice that we replaced x, and a is the exponent for x. So let me just make this clear that we're doing 2 of these, not just 2 of the one. So if you do replace negatives in place here when there's an exponent involved, make sure you put in parentheses because I forgot to do that there. But you can see here, this is really -1. So we have 2 of those in the parentheses, 2 of these multiplied together, which is +1. So that's going to be 1 minus -4 to the third power. We're still in the parentheses, so we have to subtract next. So I'm going to get 1 minus -4. I know that's equivalent to just adding 1 plus 4. So keep, change works here. Keep it, change it. And then we simplify in here. We get 5. And now, still working with the parentheses, we're done. So we just got to do the exponents for this. 5 to the third power, that means 5 times 5 times 5. 3 of these together, multiplied, which gives me 125. And therefore, bring down a negative. So you can see my answer here is -125. In this example, we have to simplify. Simplify means you just have to eliminate the common factors between the numerator and your denominator. So I know the numerator is just 3. If I did a prime factorization of 9, that would be 3 times 3. And here, we have a common factor of 3. If I eliminate these, you can see here we're left with a 3 on the bottom. If you notice there's no number left up top, I could just put a 1 here because 3 times 1, it's still 3. So I'm not changing the value. So this is actually just 1/3 as my final answer. Next example, simplify again. We have 9, prime factorization, that would be 3 times 3. 12, I know I could break that down to 3 times 4. I know we have a common factor of 3. I could break this up more to 2 times 2, but this is prime factor is 3. There's no 3 in this number here. Therefore, my answer is just going to be 3/4. In other words, if I were to expand this out more to its prime factorization, I would get 2 times 2, but notice they have nothing in common. That's why I didn't bother doing a prime factorization of 4. So here, no common factors. That's why we get 3. Multiply these back together, and you get 4. So 3/4 is the simplified version of 9/12. Next example, again, don't get intimidated when you see a lot of variables and it looks complex. Same steps to follow is to substitute first and then simplify. You just got to be very careful because the very first step of substitution is critical when you're involving negative numbers like this. So be very careful. I'm going to follow my previous recommendation, and since we have subtraction involved, I'm going to rewrite it as addition. So this, if I write as addition, it'd be keep it, change it. So this is the same as -r plus -2s over 6r. And again, keep it, change it. So it'd be plus -s. Now I'm going to substitute, again, my values here. So I get negative. What is the value of r? R is -1, so I have a -1 here. So I'm going to erase that real quick here. And we're actually going to put it in parentheses since I'm substituting a negative. So, because this is an area where you might get confused. -r. We have to replace r, right? So I'm going to put a parenthesis here. Around, I'm replacing this r here. I'm not replacing the negative, just the r. So that you can see here, when I eliminate the r, because substitution means take this out and put the other one in place of it. So in place of this r is a -1. So notice that does not, again, take into account that other negative that's in front. Bring this down, plus -2. This means you're multiplying together, 2 times s. And then what is s? S is -2, so times -2. And just in case that this didn't make any sense, I'm just going to bring this over here as some side work. -r, remember, how many r's do you see here? we have just 1. So that is the same thing as just saying negative 1r. And remember, a number next to a variable means you're multiplying it together. And what is the value of r? R is negative 1. So we're just doing negative 1 times negative 1, which is going to give me a positive 1. So you can see here, I end up with the same thing, negative 1 times negative 1. You see a double negative, that's just going to end up being positive 1 in my next step. So I recommend doing it this way if this doesn't make sense. Then on the bottom we have 6 times r, so 6 multiplied with r, which is, again, negative 1, so times negative 1, plus, and then it's a negative, and what's the value of s? So I'm going to do the same thing here before I even mess with it. So negative s is the same as just saying negative 1s. And again, negative 1s means negative 1 times s. So we're multiplying s, which is, again, negative 2. And when you multiply that together, you get positive 2. So I can actually just put down as positive 2 because I did the work over here. So I know that when I substitute my s here, I'm only going to get positive 2 there. But let me just rewrite it as negative 1 times s again, which is negative 2, just so that we follow the flow a little bit better. And now I'm going to keep doing order of operations now. Once the substitution is done, order of operations. So I already know we're going to get negative up top. Negative, negative 1 means this is just positive 1. So in here, 1 plus negative 2 times negative 2 is negative 4. And here we have multiply and add. We multiply first before adding, so we get negative 6 plus, same thing here, multiply this, we get positive 2. And then I'm going to keep doing order of operations up top. So in the parentheses, 1 plus negative 4 is negative 3. That was in the parentheses. Notice that negative on the outside is still there. And now negative 6 plus 2 is negative 4. And don't forget, if you have a double negative like this, negative times negative is positive, so we just get 3 over negative 4. If we want to just make the formatting a little bit better, we would just write it as negative 3 over 4. So from the previous examples, it does help to write how many x's you see there. In this case, again, if there's no coefficient, this is what we call a coefficient. This has a 4y, 3x, 6y. If there's no number there, we could automatically put a 1 there. I think that's going to make your life a little bit easier because negative 1x means we're multiplying these together. So we just got negative 1 times x minus 4 times y. We're multiplying. Negative 6 times y minus 3 times x. So again, this is basically translates to this right here. So I highly recommend this step right there. So you can see here I replaced all my values. X was negative 2, y is negative 1, y negative 1, x negative 2. So now I'm just going to follow order of operations. Before I subtract, I got to multiply and multiply in each case here on the numerator and my denominator. Negative times negative is positive, so it's going to be positive 2 minus positive 4 times negative 1 is negative 4. Here we get positive 6 minus, and then positive times negative, negative 6. So my next step, bring down your fraction bar. 2 minus negative 4 is the same thing as just saying, right, keep, change. It's just same as saying 2 plus 4, which is 6. Same idea here. Keep, change. It's the same as just saying 6 plus 6, which is 12. And then we have to simplify our answer. 6 is the same as 2 times 3. And then 12 is the same thing as 2 times 2 times 3. Right? 2 times 2 is 4. 4 times 3 is 12. And you can see we have a pair of 2 in common, a pair of 3 in common. So now, if there's no factors left up top, remember, I could put times 1, does not change the value. So it's a 1 up top, 2 on the bottom. So 6 halves is the final answer. 1 half. And then here we have our last example. So notice that we have a coefficient in each case. So I'm just going to rewrite it as negative 2 times c minus 2 times b over 8 times b minus 4. Just as a reminder that I know I'm multiplying these together when I substitute. So I'm going to get negative 2. What's the value of c? C is negative 5. So negative 5 minus 2 times b. B is 2. So another 2. 8 times b. B again is 2. And then minus 4. So now order of operations, multiply before we subtract. We're going to get positive 10 minus 4. Here we get 16 minus 4. So when I simplify this, I get 6 over 12, which actually, we already did that problem up here. 6/12 is the same as a half. Therefore, this one is just going to be 1 over 2 when you simplify it. And just as an alternate way, you can see that 6 times 1, right, that's the same as 6. That's the same as 6 times 2. Common factor of 6 leaves us with 1 half.